Gun Control and Cybernetics. What a Cybernetic Model Tells Us. People such as those in this picture demand gun control driven by emotional pressures, while ignoring the sometimes counterintuitive nature of the loss of control, the loss of cybernetics. Control, contrary to what politicians think it is not about exerting authority, but about getting the results you want. So let's see how management cybernetics modeling can help us understand the negative effects of gun control more objectively, keeping the preservation of constitutional freedoms in mind. Cybernetics, unlike physics and chemistry, does not deal with exchanges of matter and energy. It deals only with the parallel world of information. Information is the opposite of entropy, chaos, and disorganization. Information is about getting control and preventing some sort of disorder. Feedback information helps a guided missile hit its target. The foremost cybernetic law of control is simple. Only variety absorbs variety. Variety is a technical term to talk about the number of different states a system can portray. The more variety a system has, the more complex it is, and the more difficult it is to control. In plain English, this cybernetic law control says that if you want to have control of a system, any system you can think of, then you need as much variety in the regulator as the variety exhibited by the system you want to control. Here, in this example, the TV remote will let you access any of the different channels or picture sizes or volume that the TV is capable of. Another example of requisite variety being applied in everyday life. It makes a lot of sense, and yet people ignore it because we take it for granted and didn't even know it existed or even had a name. This is a simple equation, but achieving requisite variety can sometimes be very hard or even impossible. To have control is to have a situation where regulator's variety is equal to or greater than regulated system's variety. In this illustration, the tamer has acquired requisite variety by training the big cats to stay calm. To have control is to be in a situation where, for instance, the riot police control variety is equal to or greater than the disturbance variety coming from the crowd of protesters. In this photograph, the police stand their ground. Shouting at them is sort of okay. Control is lost when the equation is reversed. Now you have a situation where the regulator variety is smaller than the regulated system variety, or control variety less than disturbance variety. In everyday practical terms, the cybernetic law control translates into two strategies. Let's look at two examples for the first strategy. In football, the number of offensive and defensive players on the field is the same. In defending your family against looters, bandits, or assassins, for every intruder, you need someone to counteract his every move. The first strategy of control is one-on-one coverage. But things are not always so straightforward. Strategy number 2. It applies when the system to be controlled is more complex and has much greater variety, and therefore more things can go wrong. See, inside the red circle on the left, and compare it to the smaller variety of the regulator shown to the right. In strategy number 2, control is still possible, but only through variety amplification or variety attenuation. Following the home intrusion example, variety increases if there are several intruders, or they come in at night, they have weapons, and are ruthless and desperate. Variety is an abstract and very powerful way of handling the information component of the control system. Whether the intruders are more powerful, more numerous, more dangerous, heavier, or whatever variable you want to control, it translates into variety. The regulator, shown on the right, must abide by the Conant-Ashby theorem of control that says the regulator must contain a model of the system being regulated. For instance, a heater's thermostat design anticipates a wide range of changes in the weather. I will say it again. Control requires matching the variety on both sides of this variety equation. One way to match the variety on both sides of the control equation is to use one or several variety amplifiers, shown here with an amplifier symbol inside the red circle. The other part of the solution is to use an attenuator or filter of some sort to reduce incoming variety. These graphs give you some examples of attenuators that could be used against home intruders. Then you have several amplifiers shown inside the red circle. These are, for instance, a gun, alarm, neighbors, spy, night vision, or karate. You can always combine amplifiers and filters. For instance, you have your alarm, your gun, your night vision, a safe room, took karate lessons, and have a getaway car ready just in case. However, the control equation does not discard the fact that your control system will perhaps have some natural limits. For instance, if you are attacked from the sky in drone-like fashion, there are very little amplifiers or attenuators you can use successfully, unless, of course, you are Aaron Cross and you can fool the drone to attack something else. Each control situation has its own amplifiers and attenuators, and its limits to control. In real life, fighting crime is a two-step process. The government creates a police force, and the police does its job. Shown here are the amplifiers and filters at each of the two stages. This illustration, this model, is meant to show that the environment has much greater variety than the police and the government. The reason for this is that the environment holds millions of people with all sorts of behaviors, some relevant to the law, others not so, but still they overwhelm the police force unless good controls are put in place. To go through this exercise, let's isolate the left side of the variety equation to analyze the interaction between the police and the people. The police have to deal with citizens without guns, citizens with guns, and criminals with guns. It is never easy to know who is who. The police will have to sort out the criminals from the law-abiding citizens, which is a task that imposes a burden on information processing. The law-abiding group of citizens comprise many gun owners, color orange, and folks without guns, colored baby blue. Let's identify the criminals as the diamond shape, colored dark red, dispersed among the population. The situation in this example, for illustration purposes only, gives the red diamonds a positive reading of 20 points in their favor, colored red, which means that there is criminal activity going on, not much perhaps, but it surpasses police control. We would like to have zero crime, but the output of this self-balancing homeostat has settled on the criminal side. There is crime in the streets in spite of police work, the jails, and the justice system. It is like the temperature of a room with a thermostat set at 75 degrees Fahrenheit, except in this case, nobody appears to be willingly choosing 20 points or degrees as a result. It is a whole very complex system choosing or producing and settling on its own balance point. Unfortunately, society can get used to this negative performance by the police, citizens, criminals complex system. Let's say this is the criminal variety control equation. Police variety, VP, must be at least equal or greater than criminal variety, VC. But we also know that the police cannot do their job entirely on their own, so they need law-abiding citizens on their side. By definition, law-abiding citizens are on the police side of the equation. So our equation changes to police variety plus no gun variety plus gun variety equals or is larger than criminal variety, which means that the variety of the police plus the citizens with no guns plus the variety of citizens with guns has to be equal or greater than the variety of the criminals in the other side of the equation in order to have absolute control of the streets, to have no crime at all. Now, here is where the legislator for gun control goes wrong by forcing honest, law-abiding citizens to surrender their arms. The practical consequence is that now only the criminals have weapons in the midst of unarmed citizens. Reductionist thinking, to which legislators are prone, leads them to ignore the existence of feedback loops connecting all the different variables of the system they create. Gun control laws obey a simplistic premise. The more guns in the hand of the people, the more crimes there will be. This is called linear thinking, a very common and irresponsible way to ignore complex system behavior. Through the use of our model, we can see clearly criminals benefiting from the law. Before the ban, criminals had to discriminate between armed citizens and unarmed citizens, light blue and orange dots, represented by the filter in the bottom. This computation ordinarily does not come for free, making crime more difficult. But now, the gun law just gave the criminals a free pass to commit more crimes without having to worry about armed citizens acting in self-defense. Now, the safety filter is gone. Only the amplifiers remain and have doubled or tripled in size. Plus, criminals now have a larger market. On whose side of the criminal control equation is the honest, responsible citizen? The result of applying cause-effect logic is to cancel the right to keep and bear arms. But criminals keep what they have and get some more. It seems the legislators never talk to the police doing the work in the street, who only shake their heads in utter dismay. Their jobs get worse and more dangerous. An arms race between police and criminals is a known fact of life. All of it paid by more taxes and more criminality. The plan backfires. Going back to the variety equation, let's assume that it produces a net value of minus 20 in favor of the criminals. This means the homeostat is settling against the police. Now let's do a little experiment to show how this equation works. We use some arbitrary values for every variable that produces the unwanted result. The contribution of law-abiding citizens could look something like this. This other blackboard compares the before and after equations. Before the ban and after the ban. Not only does the criminal variety increase, but the police variety side of the equation is reduced, creating a much bigger negative score for the overall security system. Before the ban, remember, the number was minus 20. After the ban, the result is minus 220. Some people will complain that this is just an arbitrary example. Of course, it is arbitrary, but it is meant to show the type of reasoning needed instead of linear logic. In this example, the criminal variety jumps to twice the previous amount, and the control differential jumps 11 times higher than the previous number. Again, this is just an arbitrary illustration. But you know what? This is the type of thing that is happening in real life and cannot be explained or even admitted by the gun control lobbyists. Criminality goes up after the honest citizens are disarmed by the legislators. This is a fact, and this cybernetics-based model explains why. In very complex systems, a small change can produce surprising results. Great Britain, Australia, and Mexico have had an increase in the number of crimes committed since their respective bans. In Mexico, more than 60,000 people are dead and 20,000 are just missing in the past 6 years. Higher casualties than the Vietnam War. Imagine how the control equation behaves with corrupt policemen working for the drug dealers. Here is one bunch of such offenders. Even policemen join to victimize defenseless citizens. Defenseless citizens are like sitting ducks. Now let's look at the solution using the cybernetic control equation. Let's say that instead of banning citizens from possessing weapons, we take a lesson from history. Remember what sheriffs did in the Old West when a big gang of hoodlums hit the bank and rode away? The sheriff deputized trustworthy citizens to help him in the chase. So now, let's explore the consequences of a similar solution and apply it to our variety equation. Now, the orange variety of the gun owner jumps to 60 on the correct side of the equation. The criminal variety diminishes at least a little. What we get is that the overall control variety, the police variety, now exceeds the criminal variety by at least 30 points. Again, these figures are arbitrary and for illustration purposes only. It is the way of thinking about the problem that is being presented. What can we deduce from our example? We have a dynamic system of interconnected variables. It shows what we have to do to create a positive balance in favor of the police and the law-abiding citizens. As law and order increases, crime no longer pays. Now at last, criminal activity will start dropping consistently. On the filter side of the equation, less and less reports of crimes come in, and this further amplifies the capacity of the police to respond to the emergency calls that still require a fast response. This is the start of a positive reinforcement feedback loop, both positive and favorable. Police are now anticipating and preventing crime from happening. This is the true meaning of control, to get the desired results. The broken window strategy is another example of a complex and dynamic system at work. Let's remember that information is control, and if every window looks fine, it works as a deterrent against crime. Strong messages are strong deterrents. Strong messages are control information. Once a broken window goes unfixed for a long time, the whole building is fair game for the vandals. Let's not make sitting ducks out of the citizens. Part 3 will examine the definitive solution to this problem and the absurdity of gun control.